All right, everybody. I want to finish up matrices real fast. Of course, it's not going to be that fast because we need to do another example or two. But I want to finish them up and make sure that everybody's on the same page with me. We all need to be able to read one of these and move it backwards to make it back into equations so that we can find the solutions. So this is the matrix as we finished it up from class the other day. 1, 2, -3, 5 across the top row, 0, 1, -2, 4, and then 0, 0, 1, -2. So this is where we were, and I want to make sure everybody remembers that the first column is supposed to represent my x's. The second column is supposed to represent my y's, and the third column is supposed to represent my z's. And then this column over here by itself, that's your answers. So they're on the other side. This vertical bar tells me they're on the other side of the equals, right? Okay. So basically what we've got here is some x stuff plus some y stuff plus some z stuff equals the number, okay? So we need to be able to go backwards and write these as equations so that we can get our final solutions. Okay, there is a more complicated system. This is just the Gaussian elimination. But if you really wanted to get really crazy with it, you can make all three of these numbers also be 0 by operating off of the other ones. And then you just have, if these were zeros, you'd have x equals 5, y equals 4, z equals -2. You'd be done. You'd have your complete and total solution there. But that takes extra time to get those zeros in there. And we're probably not going to do that. So we're going to do just Gaussian elimination. And we're going to say, okay, this first row was 1x plus 2y. It's a -3, so I can put a plus minus, but I'm going to just say that's minus 3z equal to 5. Okay. And then the second row where there's no x's, 0 x's, so I don't even have to write that one, right? But it is 1y, y. And then again, it's a plus a minus 2, so I'm just going to say minus 2z equals, and right here I've got a 4, right? So notice that this second equation, because we have a 0 out in front, we only have 2 variables to work with, right? And the third equation is even better because there's 0x, 0y, so I don't have to worry about either of those positions. This is just 1z, or z, equal to -2, okay? So this is part of my solution. Z is -2, okay? And what I said at the end of class, when I ran out of time, like I always do, is what you're going to want to do is back substitute, right? That's what it's called, back substitution. So in other words, we want to work our way backwards and we want to substitute. So you can just go way up here and plug in for z, but we don't have a value for y yet. So where I always go is just the guy right before it, okay? So this is going to be, whenever I substitute in z for -2, or I'm sorry, -2 for z, I'm going to have this equation, y minus 2 times, my z is now worth a -2, I have a solution there, equals 4, okay? And then I'm just going to solve that. So a y, this is plus 4, equals 4, okay? Whenever I go to get this guy by itself, the y value by itself, that is a -4 and a -4. They both go away, okay? So what I get is, be careful with it, this is y plus 0, so y equals, and this is equals 0, right? So y equals 0, that's part of my solution, okay? And then I go one more step back to this very original guy, and I'm going to back substitute yet again. So now I'm going to say, okay, I don't know the x guy, so I'm going to solve for x for this 3 variable guy, x, but I do know the y, plus 2 times 0, right? Well, wait a minute, we know that's going to be 0, okay? So that's okay, that's going to be easy math for us in our head. And then minus 3, because that's what the formula says, the equation says, times the z we know is worth -2. All that equal to 5. So just go back and substitute in I don't know my x, I'm going to find that. I know y is 0, z is -2. So this is my new equation for this first guy, okay? Well, like I said, 2 times 0 is just 0. This is x, this is -3 times -2 plus 6 equals 5, and I'm out of room, of course. So I'm just going to say, I'm going to subtract 6 on both sides. This is going to give me x equals, the 6 and the -6 are going to go away. 5 minus 6 is -1. Okay. So what this ends up looking like is it's actually an ordered triplet instead of an ordered pair. We're used to seeing, I'll put it right here because I'm just out of space. We're used to seeing things as pairs, right? But we've got x equals -1, y equals 0, z equals -2, right? Okay. And I always put a little bar through my z so you know that's the z. So we're sitting here, we're looking at this and we say, okay, we want to write this as an ordered triplet. So it ends up being, just put it in alphabetical order, just like we just did. -1, comma, 0, comma, -2. There you go. There's your ordered triplet. Instead of an ordered pair. When we had two equations with two variables, we did an ordered pair, right? It was my x comma y. No big deal because we're used to that being the way it is, ordered pair. But here we have three solutions because we have three variables. So yeah, we have this guy right here. Right. So hopefully you can read that and get your solutions out of it. No big deal. We're going to do another example just to make sure everybody's good with it. So I'm going to, I might talk to you a little bit and then say, okay, do this on your own. And you can pause the video and then I might pause my video on my side and get my solution and stuff like that so that we can just kind of skip a little time on the video. Okay, so here's my system of equations. This is my next example. Okay, 3x plus y plus 2z equals 31. X plus y plus 2z equals 19, x plus 3y plus 2z equals 25. Okay, so they're kind of big numbers, but hopefully they work out okay. Okay. I see going right into it that this first equation has a 3 at the beginning, but these other two have 1s on them. So I know that I'm not going to want that 3x guy on the top. I'm going to go ahead and write the matrix so that he is on the top. But I know that the first thing I'm going to do is remember what we're after. We want that inner diagonal 1, 1, 1. And I don't want to have to deal with a 3 if I don't have to when there's a 1 here and a 1 here. So I'm going to flip probably just the first and second equations whenever we get there. But here we go. Let's set up the matrix first. Remember that we're going to use it as if the first column is the x, the second column is the y, the third column is the z. We're going to have an equal, which is this hard vertical line, and then the numbers are going to be on the other side. And that's the way we are always setting up our matrix. Okay, so if things aren't in the proper order, you need to put them in the proper order before we go here. Okay, and then remember, this is like synthetic division, right? So I'm just going to deal with the numbers. I don't need these variables to be able to do this. 3, 1, 2, 31. 1, this is a 1 in front of the y. So 1, 1, 2, and 19. And then 1, 3, 2, and 25. So that's what my matrix looks like to begin with, where I'm at. In your book or in your homework, you might hear it called an augmented matrix. Augmented. So if you hear that word, I don't want you to freak out because I haven't used it. Okay. Augmented matrix just means it has the answer part with it. Okay. This would be a regular old matrix where I'm just dealing with the x, the y, and the z. But here, this means the solutions are on the right. Or I should say in the right-handed column. Okay, so that's what augmented means. It just means, hey, it has the answers with it. And for our purposes, we're never going to do any that don't have them. But just so you know, if you go on into an upper level math class, there's some stuff called matrices, matrix theory and stuff like that. And so sometimes you're just manipulating a regular old matrix without the solutions in there so that you can show stuff. So that's what's going on with that, just FYI. Okay, like I said, I am going to switch these two rows. I'm going to swap them. Okay, I don't want to have to multiply by 1/3 to clear out this 3. And if I multiply by 1/3, I'm going to get fractions, right? Whenever I can just swap them and have my 1 automatically in that top corner. So I'm going to have so my plan is I'm going to move the first 2. You could have done the third one if you wanted to, but I'm going to have a 1, a 2, and a 19. Okay, I'm going to have the 3, the 1, the 2, and the 31. And then my bottom row is going to stay the same. 1, 3, 2, 25. And I know that this ends up having, like, you do a lot of writing. This takes up a lot of space, but it's really nice whenever I don't have to deal with those variables and keep up with them, right? We just know here's my X's, here's my Y's, here's my Z. Okay, here's the solution. And as long as we stick with our 3 allowable row operations, right? The 3 legal moves that we can make, then we're okay. It's not going to be a big deal. Hang on a second. If your screen is frozen, I apologize. My camera has stopped moving. Dang it. So if this thing's for too terribly long, we may have a second video. I may just stop it so that we can see the math separately. I'm sorry about this, guys. I think it must be a function of my slow internet here at the house. Which is why I don't normally make videos out here at my house.